Question 7 says, if you have a 1,200-foot roll of fencing in a large field, you want to make two smaller enclosures by splitting a large rectangular enclosure in half. What is the length of the largest such enclosure? So the first thing it asks us to do is write an equation to model the perimeter. I have 1,200 feet of fencing. That needs to equal my two lengths, so 2L, and my three widths, 1, 2, 3, so plus 3 widths. And then it asks me to write an equation to model the area. And area of a rectangle is always length times width. Then it asks me to solve the perimeter equation for L and plug it into the area equation. So that's asking me to solve this for L. And so 1,200 equals 2L plus 3W. Subtract my 3W on each side. 1,200 minus 3W equals 2L. Divide everything by 2. And I get 600 minus 3/2 W equals L. Then it wants this to get subbed back into here for my length. So that gives me area equals 600 minus 3/2 W times W. And then for me, I think that it would be easier to find the derivative of this, which is the next question, by distributing, so that I can just use the sum and difference rule as opposed to using the product rule. So if I distribute the W in, I get 600W minus 3/2 W squared. So then it asks me to find the derivative of that. And the derivative of that is going to be 600W minus, the derivative of that is 600 minus 3W, because I bring this 2 out in front, and that would cancel out and leaving me with just that 3W. So the next thing is asking me to find an input at the max area, and in order to do that I have to set the derivative equal to 0, and that's because at the maximum point a slope is 0. So I'm going to set this equal to 0 and solve, so I get 3W equals 600. So dividing each side by 3, W equals 200. So the length of the enclosure to maximize the area, well, if this is the input, then I can plug that back into my perimeter equation here, and 600 minus 3/2 W, well, W is 200. So then I get 600 minus 600 over 2 equals L. So that's 600 minus 300. So the length of the largest enclosure is 300.